Alright, today we are going to start talking about circles. This first section is just a lot of vocabulary and notation, and then also we'll take a look at circumference of a circle, which is something you've already seen before. I'm hoping to finish up with this chapter before spring break, so that we're not in the middle of a chapter, and then trying to take a test when we come back. So that's the goal, to finish circles before spring break. So on the front here, just a little bit of vocab. The definition of a circle is just all points in a plane distance from a given point. Right? So if that distance would be the same. That distance is called the radius, and the middle of the circle is circle. So first, a segment with endpoints that are at the center and on the circle. So it's saying we've got an endpoint here and an endpoint on the circle. That's a radius. Okay. Plural is radii, right? Not radiuses. So if you want to make a note of that, it's two eyes, radii. That's the plural of radius. Imagine. Now, a segment with endpoints on the circle. So that would be like AE here. That is called a chord. Okay, with endpoints on the circle. Then a special type of chord, okay, one that passes through this, called a diameter. Yeah, so the diameter is exactly twice the radius. Because if we look at a diameter here, dB would be a diameter. That's exactly 2 radius lengths. Okay. All circles, we can say, are similar. Okay? Remember, 2 chapters ago, we talked about similarity. Right? And our definition of similarity in layman's shape, different size. Right? So all circles would fit that description. They're all the exact same shape. Then, as we just mentioned, for a circle that has a radius r and a diameter d, the radius is just exactly 1/2 of the diameter. And then, conversely, we can say the diameter is 2 times the radius. So in this circle over here, we kind of already named a few of these pieces. Some examples of a chord. We could say that AE is a chord. What's that? EA. There's the. We could also say that DB is a chord. Right. We've got a few examples of radii here. We could say that FD, FC, and FB would all be examples of a radius. And then, as it's drawn, we just have one example of a diameter. dB would be an example of a diameter. Right? And remember, a diameter is just a special type of chord, so that's why dB fits both a chord and a diameter. All right. Any questions so far on vocab? Okay. No, FC would not be a chord because both of its endpoints are not on the circle. So one of its endpoints is at the center. So we would have to have both endpoints on the edge of the circle for it to be a chord. Any other questions? Okay, so I guess the only other thing to talk about with vocab and notation is how to name a circle itself. Right? So in this example here, we always name a circle just using its center. So we would call this circle O. Now, there's two ways that you may see that written. You may see it just as a dot with the center, or you may see it as a dot with a circle and then the center. Right? This is probably the more common way that you'll see it, okay? But you may also see it written like this, okay? Just, in the same way that we have a triangle and then we would name it triangle ABC, and we'll just put a dot and then the center of the circle, but sometimes you may see an actual dot with a circle around it and then the center of the circle, okay? Then this just says name all the radii we can see of the circle. So I think I see 4 of them. What would they be?
OA, OC, OD, OD.
Yeah. OA, OB, OC, OD. Hopefully no OD. What about chords in this circle? AB would be an example of a chord. What else? CD. And I think that's all the chords in this circle that we can see drawn in. All right. Questions? All right. Then 2 here, and try this one. So these ones we're just kind of thinking backwards. So if we're just thinking about this as like 1 minus 2 sine squared of theta or something, what formula did we talk about it? This equals. Yeah, so 1 minus 2 sine squared. So we would say this is equal to cosine of 2 theta. Okay, so this is just cosine of 2 theta. So we can say that pi over 6.
No, I'm tired.
6. 2. Pi over 6, or I'm sorry, pi over 12.
Yeah.
All right, did we get these answers?
Yeah. Yeah.
Wait, AX and B words. They are. Oh, yes. Be proud of me. What? Oh. Ooh.
What questions do we have on this notation, diameters, radii, anything on these? All right, then let's flip over to the back. Summer, I'm so proud of you for being on time. We use the pi button. Well, that's kind of silly. All right, so on the back, we're going to take a look at circumference. Right? Circumference is just the perimeter of a circle. Right? It's just the distance all the way around the circle. So we have essentially two formulas, but they're really the same thing. Right? Circumference we could either say is pi times the diameter of the circle, or 2 pi times the radius. Right? Because we know the diameter is equal to 2 times the radius. So these two formulas are interchangeable. So in this first example, we're given the radius. So we can say the circumference is equal to 2 pi times 13. So it says round to the nearest hundredth. So we can just put this all into the calculator. We want to be as precise as possible, so we're going to use the actual pi button on the calculator. Does everybody know where that is? So on the yellow calculators, it's all the way on the right, the second button down. Okay, you have to hit second, and then call it a caret. And so second caret will get you the exact value of pi on your calculator. So 2 times pi times 13. What does that give us? 81. My favorite shape. Oh yeah, I just made something up last night. Didn't I say like a dodecahedron or something like that? Well, it is. But it's not necessarily Alright, so that's the basic idea for finding circumference. Right? So this is stuff you've done in middle school before, right? Just plugging numbers into the circumference formula. So let's go backwards now. Right? Let's say, well, given the circumference, what's the radius and the diameter? For this first example, we know that circumference, if I first want to do the radius, circumference is 2 pi r. So if I know the circumference is 40, I can say 40 equals 2 pi r. So to get r by itself, I would have to divide by 2 pi. So over here, the 2 pi would cancel out. Now, when you're putting this into your calculator, you have to be careful. If you just type it in like this, you're going to get the wrong answer, right? Because what you're telling your calculator to do if you type it in like that is take 40 divided by 2 and then multiply it by pi. That's not what we want to do. So when you are putting this into the calculator, you need to make sure that you put parentheses around the 2 pi. Right? That will tell the calculator to divide 40 by 2 pi. For this, it doesn't matter. What is 40 divided by 2 pi? 6.36. 6.37. So our units would be in inches. Yeah, so then to find the diameter, we can just take our answer for the radius and multiply it by 2. So 6.37 times 2 would be 12.74. Say what? Well, 6 times 2 is 12. 30 times 2 is 60. And 7 times 2 is 14. So I just added that together. Well, you can do 37 times 2 in your head.
Well, yeah, right? What's 35?
So,
I'm just saying, like, what I did isn't that impressive, but you can do it too.
When I look at 6.37, I'm like, oh, I need to, like, whatever you did, it just feels like so much.
But it's really not. If you split it up, just do 6 times 2. Less.
Thank you.
And then 30 times 2. And then 7 times 2.
And then
And then add it together.
I could probably do a little
Alright, so let's take a minute and try a couple of these. We don't need to do all 5 of them, but let's at least try 1 or 2 of them here.
Yes, I did. It was 1,200 something. At least one pencil too. Oh wait, I found it. Oh. Whoa. I need to borrow that. No, shut up. I'm getting us some answers. What? No way. Wait, I have to find the diameter. Oh wait, that's a given circumference.
Isn't that crazy?
Yes, I can do that. To what? Okay, yeah. What is that times half?
Bless you.
16, what?
Oh,
So round to the
Yes, there are. Bless you. Good thing we just talked about how to find missing sides of
Oh
a
wait,
triangle.
that kind of radius or
Yes,
the...
whenever you do the 2 parts, you divide the 2 parts.
But I don't know how to do it.
Of course. Of
I
course you
agree.
would say that. Yes, I gotta do math.
Can you calculate
Not
it?
actually.
64.98.
Really bad.
98.
Your time didn't end by 3.
Oh my god. Yo, put it on me. I can swim with just
Alright, for those that you tried, right here are some answers. And diameter is obviously listed first, then the radius. No, it doesn't matter what order you write it in, just as long as you specify which one's which. Alright, so I guess on the first one, if we're talking about rounding, they didn't take the rounded answer and double it. They took the unrounded answer and doubled it and then rounded it. Okay, so if you take this unrounded answer, which was what, like 6.36 something something something, and multiply that by 2 and then round it, it would actually get 12.73 instead of 12.74. Okay. Yes, right. So we talked about before, right? And for an intermediate step, always go a few extra decimal places and then only round your final answer. So in this case, that would be true of finding the diameter. We could call the radius an intermediate step.
Okay, so if we can't find the calculator, we just take the number times by 2.
Yeah, you can just hit times 2 in the calculator. I know. Yeah. Okay. So any questions on these ones? So then the last thing that we can take a look at here is finding the circumference if we aren't given a radius or a diameter. So in a lot of these, we have right triangles inscribed in the circle. Okay, and I guess a vocab word that we haven't really talked about are two vocab words: inscribed and circumscribed. Right, so inscribed means the shape inside the circle, but there's a little bit more to it, such that all vertices are on the circle. Okay, so if we look at each of these triangles, or in this case a rectangle, that are on the inside of the circle, all vertices touch the edge of the circle. Right? Circumscribed then is just the opposite. It's a shape that is outside the circle. Yeah, exactly. Yeah, inscribed is inside the circle. Circumscribed is outside the circle. Okay. There's a little more to this one as well, such that all sides are tangent to the circle. Now, tangent here means touching, right? Tangent means touching the edge of the circle. So inscribed means inside the circle, circumscribed means outside the circle. Right? So, if our ultimate goal for all of these is to find the circumference of the circle, I need to know either the diameter or the radius. Right? So if I look at this first triangle, I know the two legs. Right? We have to find the hypotenuse. So if I know two legs, easiest way to find the third side is the Pythagorean theorem. What's that? Yeah, a squared plus b squared equals c squared. Now, I was just going to ask that, if anybody recognized that. Right? If you recognize that this is a Pythagorean triple, you can save yourself a little bit of work. Okay, it would be 10. This is a multiple. Wait, what?
I mean, you gotta do
Well, if you recognize that it's a Pythagorean triple, you don't have to do the work. That's the whole
the work.
point.
And you're just expanding, getting better.
Doing something repetitive that you already know the answer to doesn't expand your brain.
I don't know.
It's taking something and applying it to a new situation that expands your brain. So yeah, if you don't know that this is going to be 10, then sure, go through the process of the Pythagorean theorem. So we would have 36 plus 64 equals c squared. That gives me 100. And then take the square root of both sides. And we get 10. Not quite. So we want to find the circumference then. So if I know the diameter is 10, I can use my formula that the circumference is just pi times the diameter. Now, the directions say, give me the exact value. If we type in 10 times pi in the calculator, it's going to give me a decimal approximation. Whenever the directions say, find the exact value, we can leave our final answer in terms of pi. So I can say that this is just going to be pi times 10. Right? But the conventional way to write that then would be to write the pi second. So I can say that the circumference is 10 pi, and then we'll tack on our units of centimeters. Okay. So if it says find the exact value, we don't have to put it in the calculator. We can just leave it in terms of pi. So if we put it in the calculator, it's no longer exact. We're getting a decimal approximation. Yeah, if you do plug this in the calculator and round to the nearest hundredth, it would be 31.42 centimeters.
How does 10 go for?
It's just kind of the convention of how we would write a coefficient and a variable. Like if you think about if we have x times 10, we're not going to write it as x10. We're going to write it as 10x. It's the same idea. That's the convention. Write the number first. Even though in this case these are both numbers, it's still a symbol. So we would still use this convention of how we write variables. Alright, so questions on that idea? All right, let's take a couple of minutes and try a few of these then.
There's a measure circle.
Well, you can't use a ruler, but one thing you could do is take a piece of string,
What is that?
put it around the
What is that
circle,
one?
and then measure the string.
Or a weird thing.
Is it- I don't think we can do that on the test.
Because they're not always drawn to scale.
And this is 11 inches
So,
long. I'm done. It says years.
Stop, actually.
Tell me the answer for me.
Mine's at 40.
Of course you got that. Of course. Why would oh, wait, how do you even do this one?
Okay, so this side is not. This side is not.
What? What are you talking about? How do you do 10? How do you do 10? How do you do 10?
If it's touching both of these sides, and it's 11 yards here, it would be 11 yards there.
Yeah, that's a couple kind of diameter.
The diameter is going to be
11.
11 high.
No, that's the circumference actually.
7.
Oh,
Yes, that's exactly it.
What was that?
I said in 4th grade, you went on the playground and screamed, "I'm gay and I'm proud."
Yeah, I mean, nothing. Nobody said your name.
Rachel always wants
Rachel always needs to turn channel. This guy's a I don't know his name. He's name at girls.
Okay, I got a freaking
So you
Like that.
so largest.
Oh, that looks like yeah. Okay, we should do
We didn't do any problems just like the one, but I mean it was an extension of
I know we're gonna do it. So this would be ongoing special time to what?
Yep.
we're not paying so how are you?
Okay, so think about the side of the two circles. If it's top to bottom there, it's so eleven pounds. Same thing.
They're advancing like ritualizing.
It is pretty power though.
We're definitely not doing.
Fire.
We're definitely not doing. Some it just be like
What about so
I think solar. Yeah. I wish to see it.
All I have to do is run a quick thing. I'll probably do it. Yeah, I can I'll tell Matt to stop. I'll tell Matt to stop distracting.
That's exactly what he did last week. But you have that idiot now. Why is that idiot? Oh, wait, no. Just schedule something, right? Scheduling change at all. Live in photography, so art. I'm excited to see my schedule next year, though. Right? Yeah. Yeah. Watch me have outage with my buddy. Singing on the bush.
I'm looking on it.
I'm mad.
Oh no,
Oh no.
For my base.
Oh no. Oh no, Rachel. Oh no. You're done. What? Are you high? Brain became this.
yeah, there's lots of correct answers.
Okay, I was like trying to figure out just more like
Brain came to school
so I just find out
high.
what's the whole number.
Rachel, Brain came to school high.
But yeah, I
Oh,
think you
great.
can put the points on.
I don't have
What's 81 times 2? Yeah?
Let me say it's a triangle. That's a special triangle. So it can just be 9 and the square root of 2.
Did I ask?
No, you're saving you so much time.
Side leg, it's on there.
Let me go find something to ask.
Okay.
Not always, no.
I know my way on that website.
Yeah, but I'll be right back until I find something to ask. What is this?
Give me the calculator.
Give me the give me the money.
Alright, did we get these answers here?
Now, let's see.
Yes.
Which ones do we want to take a closer look at?
Well, I got to mine.
So, a couple of things I would like to point out, I suppose. On number 8, if I know that these two sides are the same, if they're both 9, if I have an isosceles right triangle, that automatically makes it a 45, 45, 90 triangle. So if we remember our relationships between the sides, I can just take one of the legs and multiply it by the square root of 2. So in a 45, 45, 90, I would get, if the leg is 9, the hypotenuse is 9 times the square root of 2. If you don't remember that or don't recognize that, you can always use the Pythagorean theorem. But then we would want to simplify the root that we get at the end. Right? So I think if you did use the Pythagorean theorem, you get the square root of 162 for the hypotenuse. Then we're just looking for the largest perfect square that divides evenly into that. 81 goes into that, so I could split this up into the square root of 81 and the square root of 2. And then the square root of 81 is 9. So we would get the same answer either way. But if you recognize that this is a 45, 45, 90, you can save yourself a little bit of work. Just like if you recognize this was a Pythagorean triple, you save yourself a little bit of work. But if you don't recognize that, it's okay. You can always use the Pythagorean theorem. Another thing, on number 10, this length of the side of the square is just the length of the diameter. There was nothing to solve for on this one. And we were just given the diameter. So the answer for the circumference is 11 pi. Any other questions on these?